Hello! Today we're going to explore a very useful set of tools in mathematics, divisibility tests. By the end of this video, you will be able to explain what divisibility tests are, apply the tests for 6 and 12, and use a shortcut to find decimal answers for division problems that don't divide evenly. So what exactly are divisibility tests? They are simply quick rules that allow us to determine if one number can be divided by another number without leaving a remainder. In other words, they help us check if a number is a factor of another number. Why are these tests so useful? Well, they can save you a lot of time. Instead of performing long division, you can use a simple test to see if a number is a factor. This is especially helpful for simplifying fractions, finding common denominators, and solving various math problems more efficiently. Think of them as mental shortcuts that make arithmetic easier and faster. They are a powerful tool for building number sense. Let's start with the divisibility test for 6. Our goal here is to learn how to quickly tell if a number is divisible by 6. The key to understanding this test lies in the prime factorization of 6. The number 6 can be broken down into its prime factors, which are 2 and 3. This means that for a number to be divisible by 6, it must be divisible by both 2 and 3. If it's missing either one, it's not divisible by 6. So the rule is, a number is divisible by 6 if and only if it is divisible by both 2 and 3. Let's quickly recap the tests for 2 and 3. A number is divisible by 2 if its last digit is an even number, 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of its digits is divisible by 3. Now let's put this into practice with an example. Is the number 432 divisible by 6? First, let's check for divisibility by 2. The last digit of 432 is 2, which is an even number. So yes, 432 is divisible by 2. Next, let's check for divisibility by 3. We sum the digits. 4 plus 3 plus 2 equals 9. Since 9 is divisible by 3, 432 is also divisible by 3. Because 432 is divisible by both 2 and 3, we can confidently say that it is divisible by 6. We've met both conditions. Let's try another one. Is 514 divisible by 6? First, check for 2. The last digit is 4, which is even. So 514 is divisible by 2. Now check for 3. The sum of the digits is 5 plus 1 plus 4, which equals 10. Is 10 divisible by 3? No, it's not. So 514 is not divisible by 3. Since 514 is not divisible by 3, it cannot be divisible by 6. Remember, it must pass both tests. Finally, let's look at 729. Is it divisible by 6? First, check for 2. The last digit is 9, which is odd. So 729 is not divisible by 2. We don't even need to check for 3. Because it failed the test for 2, we already know it's not divisible by 6. It must be divisible by both. So we've now learned how to apply the divisibility test for 6 by checking for divisibility by both 2 and 3. This is a powerful technique that connects different divisibility rules. Now, let's move on to the divisibility test for 12. Our objective is to learn how to determine if a number is divisible by 12. Just like with 6, we can break down 12 into its factors. The number 12 can be factored in a few ways, but the most useful for our test is 3 times 4. Why 3 and 4? Because 3 and 4 are relatively prime, meaning their greatest common factor is 1. This is a crucial condition for this type of test to work. So the rule is, a number is divisible by 12 if and only if it is divisible by both 3 and 4. We already know the test for 3. The sum of the digits must be divisible by 3. Let's quickly review the test for 4. A number is divisible by 4 if the number formed by its last 2 digits is divisible by 4. Let's try an example. Is the number 756 divisible by 12? First, let's check for divisibility by 3. The sum of the digits is 7 plus 5 plus 6, which equals 18. Since 18 is divisible by 3, 756 is divisible by 3. Next, let's check for divisibility by 4. We look at the last 2 digits, which form the number 56. Is 56 divisible by 4? Yes, 56 divided by 4 is 14. So 756 is divisible by 4. Since 756 is divisible by both 3 and 4, it is divisible by 12. We have successfully applied the test. Let's try another one. Is 240 divisible by 12? First, check for 3. The sum of the digits is 1 plus 2 plus 4 plus 0, which equals 7. Is 7 divisible by 3? No. So, 240 is not divisible by 3. Because it failed the test for 3, we already know it's not divisible by 12. It must pass both tests. One more. Is 138 divisible by 12? First, check for 3. The sum of the digits is 3 plus 1 plus 3 plus 8, which equals 15. Since 15 is divisible by 3, 138 is divisible by 3. Now, check for 4. The last two digits form the number 38. Is 38 divisible by 4? No, 38 divided by 4 is 9 with a remainder of 2. So, 138 is not divisible by 4. Since it failed the test for 4, it is not divisible by 12. It must pass both tests. We have now successfully applied the divisibility test for 12 by checking for divisibility by both 3 and 4. This method is a great way to break down a complex test into simpler, more manageable ones. What happens when a number isn't perfectly divisible by 6 or 12? Our next objective is to learn a shortcut for finding the decimal answer without long division. This shortcut is based on the fact that 6 is 2 times 3. We can divide by 6 in 2 steps, first by 2 and then by 3. This is often easier to do mentally or with simple calculations. Let's try an example. What is 15 divided by 6? First, we divide 15 by 2. This gives us 7.5. Next, we take that result, 7.5, and divide it by 3. This gives us 2.5. So 15 divided by 6 is 2.5. Let's verify this with a calculator. 15 divided by 6 is indeed 2.5. This two-step process is much simpler than setting up long division. Let's try another one. What is 27 divided by 6? First, divide 27 by 2, which is 13.5. Then, divide 13.5 by 3, which is 4.5. So 27 divided by 6 is 4.5. Notice how we're just breaking the division into two easier steps. This is the power of understanding the factors of a number. Let's do one more. What is 45 divided by 6? First, divide 45 by 2, which is 22.5. Then, divide 22.5 by 3, which is 7.5. So, 45 divided by 6 is 7.5. This shortcut works every time, because dividing by 2 and then by 3 is mathematically equivalent to dividing by 6. It's a great way to find decimal answers quickly. We can apply the same logic to division by 12. Our objective is to learn a shortcut for finding the decimal answer for division by 12. Since 12 is 3 times 4, we can divide by 12 in 2 steps, first by 3 and then by 4. This is often easier than long division. Let's try an example. What is 30 divided by 12? First, we divide 30 by 3, which gives us 10. Next, we take that result, 10, and divide it by 4. This gives us 2.5. So, 30 divided by 12 is 2.5. Again, you can verify this with a calculator. 30 divided by 12 is indeed 2.5. This two-step process is a powerful alternative to long division. Let's try another one. What is 54 divided by 12? First, divide 54 by 3, which is 18. Then, divide 18 by 4, which is 4.5. So, 54 divided by 12 is 4.5. This method is especially helpful when the numbers are a bit larger, as it breaks the problem down into more manageable parts. Let's do one more. What is 78 divided by 12? First, divide 78 by 3, which is 26. Then, divide 26 by 4, which is 6.5. So, 78 divided by 12 is 6.5. This shortcut for division by 12 is a fantastic tool for finding decimal answers quickly and accurately. It reinforces the idea that understanding factors can simplify complex calculations. Now let's apply these ideas to a couple of homework problems. Our objective is to use the divisibility tests and shortcuts to solve problems. Here's our first problem. A baker has 056 cookies. Can she arrange them into boxes of 6 with no cookies left over? If not, how many cookies are in each box if she uses 6 boxes? First, we need to determine if 1056 is divisible by 6. We'll use our divisibility test. Step 1. Check for divisibility by 2. The last digit of 1056 is 6, which is even, so yes, it's divisible by 2. Step 2. Check for divisibility by 3. The sum of the digits is 1 plus 0 plus 5 plus 6, which equals 12. Since 12 is divisible by 3, yes, it's divisible by 3. Since 1056 is divisible by both 2 and 3, it is divisible by 6. This means the baker can arrange the cookies into boxes of 6 with no cookies left over. The first part of the question is answered. Now, how many cookies are in each box? We need to calculate 1056 divided by 6. We'll use our shortcut. First, divide 1056 by 2, which is 528. Then, divide 528 by 3, which is 176. So there are 176 cookies in each box. By using the divisibility test and the shortcut, we solved this problem efficiently. The baker can arrange 1056 cookies into 6 boxes with 176 cookies in each. Let's tackle our second homework problem. Our objective is to apply the divisibility test and shortcut for 12. Here's the problem. A school needs to transport 172 students to a field trip. Each bus can hold 12 students. Will every bus be full, or will there be a partially filled bus? If there's a partially filled bus, how many students will be on it? First, we need to determine if 172 is divisible by 12. We'll use our divisibility test. Step 1. Check for divisibility by 3. The sum of the digits is 2 plus 1 plus 7 plus 2, which equals 12. Since 12 is divisible by 3, yes, it's divisible by 3. Step 2. Check for divisibility by 4. The last 2 digits form the number 72. Is 72 divisible by 4? Yes, 72 divided by 4 is 18. So yes, it's divisible by 4. Since 172 is divisible by both 3 and 4, it is divisible by 12. This means every bus will be full, and there will be no partially filled bus. The first part of the question is answered. Now, how many buses are needed? We need to calculate 172 divided by 12. We'll use our shortcut. First, divide 172 by 3, which is 724. Then, divide 724 by 4, which is 181. So, 181 buses are needed. By using the divisibility test and the shortcut, we quickly determined that 181 buses are needed, and every single one will be completely full. This is a great example of how these tests can help us solve real-world problems. Let's quickly recap what we've learned today. Our objective was to understand and apply divisibility tests for 6 and 12, and to use shortcuts for division. We started by defining divisibility tests as quick rules to check for remainders, which are useful for simplifying calculations. We learned that a number is divisible by 6 if it's divisible by both 2 and 3. We also saw that we can divide by 6 by dividing by 2 and then by 3. Similarly, a number is divisible by 12 if it's divisible by both 3 and 4. And we can divide by 12 by dividing by 3 and then by 4. We've now met all of our learning objectives. You can explain divisibility tests, apply the tests for 6 and 12, and use the shortcuts to find decimal answers. These tests are powerful tools that can make your math journey much smoother. Keep practicing them, and you'll find yourself solving problems faster and with more confidence. Thank you for watching.